We're going to start in just one moment. Absolutely delightful to see so many people out this evening. Good evening. My name is Sally Bennett-Olzak, and I have the great honor of serving as the CEO of the Alzheimer Society of Windsor and Essex County. Thank you for being here. It's my great pleasure to welcome each of you here to our first ever Research Day, again presented by the Alzheimer Society of Windsor and Essex County. Research is currently underway, certainly around the world, for treatment of Alzheimer's disease and related dementias, and certainly, moreover, for a cure. Today, we proudly showcase national-level research from our Alzheimer Society Canada office, and proudly also local research being conducted here at the University of Windsor. We're delighted to share this event with you here in this space at Art Windsor Essex. And thank you to Art Windsor Essex for having us here. They've been so gracious in letting us utilize their wonderful event space. And we have an exceptional view of the Detroit River for you, the GM Renaissance Center in downtown Detroit, and incredible record-breaking warm temperatures today. Our board chair is here representing the organization, and our board has sponsored this event. Ms. Karen Hall is way at the back. Her hand is up. She has a striped blue and white dress on with a lovely black jacket. And feel free to chat with Karen afterwards. She loves to speak with people. This morning, we had Dr. Robert Gordon, President and Vice Chancellor of the University of Windsor, present, who took time out of his very, very busy schedule to join us, along with Dr. Shanthi Johnson, VP of Research and Innovation. They send their regrets for this evening, but we were very honored to have them in our presence. Our organization continues to enjoy a robust and beneficial partnership, certainly with the University of Windsor and its students and researchers. I'm very excited to introduce our esteemed researchers who will be presenting to you today. Our first presenter will be Dr. Joshua Armstrong, who's right here. Dr. Armstrong is our Alzheimer Society of Canada National Research Scientist. The Alzheimer Society of Canada is located in Toronto, and Dr. Armstrong has joined us from Thunder Bay. He flew in yesterday. I'm not sure if Eugene Van Wyck is in the room here, but I want to acknowledge Eugene. He is our Manager of Fund Development and Community Engagement, who has put today's events together. Two identical events, one this morning and one this evening. And Eugene was wise enough to arrange a total eclipse of the sun for Dr. Armstrong's arrival. Problem is the flights didn't quite align, so while our friends in particularly the southern part of the county enjoyed the total eclipse, those of us here in Windsor maybe a 80–90% eclipse. Dr. Armstrong was at Pearson International Airport standing at the window at 2 to 4 o'clock looking out to see the eclipse and wait to board the plane. To soothe his loss of not seeing the total eclipse, we took him to a local brewery last night, our senior team of officers, and we had a great night. We had hoped to have Dr. Jerome Cohen here today, known to most people as Jerry Cohen. Dr. Jerome Cohen is out of the Department of Psychology, Professor Emeritus at the University of Windsor. As some of you may know, Dr. Cohen had heart surgery in London, Ontario on March 20th. And we ask for your prayers. He's in ICU, and there's a bit of a struggle going on for Jerry. We are praying very much for him, but our latest update as of today is he appears to be on the upward trend, but he's here in spirit. We have Dr. Siyaram Pandey from the University of Windsor, who will present later. Welcome, Dr. Pandey. And we have Ms. Keanna Dube, or Dube, depending. And Keanna has her father here tonight. Where is your father? Right there. Welcome, Mr. Sean Dube, however we're pronouncing it, or Dube, I'm not sure. Welcome. Keanna shared with me today how delighted she was that her father would be here. The future Dr. Dube is a doctoral candidate research assistant at the University of Windsor. She will wow you with her expertise as the night unfolds. The biographical information for all of the researchers is located in your large white package. Please take time to look. We would be here until tomorrow morning, or maybe another eclipse, to go through all of their fine work. Most impressive. And enjoy what we have for you in the package. Quick housekeeping information: out the back to the left where you came in off the elevator, to the right of when you came off the elevator, are the restrooms if they're needed. And we have lots of refreshments. Help yourself on the way out tonight. Please take some for the road. That's very much our culture at the Alzheimer Society, to break bread, take care of people, and nothing goes unused. We share at all times. As for the order of the event, we'll have each researcher present, and the way the timing went this morning, there's enough time for 10-15 minutes or so of Q&A at the end. We should be done right around 8 o'clock. We're in no hurry to get out the door. A lot of people here know each other or meeting people for the first time. Take time to socialize after. By all means, it's so nice to be together under the same roof. We're live streaming today. We have Francois Jacques with his company MacFlash. There's a little room to the side, and he set up all of the technology. So thank you so much to Francois and MacFlash, who's a wonderful community partner to us. Welcome to everyone near and far who's live streaming, and on our website, the link will be there for you to watch this afterwards, and we'll be using this material over and over as we continue to share the information with people over the coming year or two. It is with great pleasure that I welcome Dr. Joshua Armstrong to the podium.
Thank you so much for being here. Thanks for having me. It's wonderful to present some of the work that we've developed at the Alzheimer Society of Canada. So today I present to you the Many Faces of Dementia in Canada, some highlights from a fairly large report that I think you all have in your white bags. Sorry, just trying to advance slides. Yeah, I think it worked. Oh, too far. Oh, so we've known for many years that we can expect the number of people living with dementia to rise fairly rapidly in Canada with the aging of the population. So here I share what used to be called a age pyramid of Canada, and you can see that baby boomer cohort moving up. And as those baby boomers get into their 70s and 80s, we expect them to drive the number of people living with dementia up, because age is the #1 risk factor for dementia. Back in 2010, the Alzheimer's Society of Canada developed the Rising Tide report that looked at some of these projections. What we wanted to do with the landmark study is to update those, use more recent trends, more recent data to get a really better sense of how dementia will impact Canadians from 2020 to 2050. From the landmark study, we're producing 3 reports. 2 of them are now out and available on our website. The first report, Navigating the Path Forward for Dementia in Canada, contained a lot of the projections, looking at what numbers to expect over that 30-year time period. So a chapter on care partners, a chapter on risk reduction, and how that could have an impact on those numbers. For the second report, which I'll be covering today, we break down some of those projections to look at the population and examine the people who will be experiencing dementia over that time period. We're going to follow this up with a report on economics, layering onto that the dollar figures. What would it cost to take care of people living with dementia over that 30-year time period? What the landmark study model is it's a micro-simulation model. It's all data-driven. Take data from the Canadian government, things like the 2016 census, and recreate the Canadian population so we get a better sense of how it will change over time. On top of that, we layer health data. So each Canadian is represented by what's called an agent. They have a health status. They could have family members. And we see how that changes over a 30-year time period. Excuse me. Kind of like SimCity. You set up a structure, and then you press play and see how it changes over time. Here we set up the Canadian population, make sure it works like we expect, and then we can look at what we might expect if current trends continue in terms of dementia status for the country. This allows us to look at different things, looking at who will experience it across different provinces, look at differences between sexes and ethnicities, all accounting for population dynamics, including immigration, death, and birth within the Canadians. So here's a little snippet from the first report, looking at some of those projections that I talked about. So by 2050, we expect a 187% increase in the number of people living with dementia. So going from just under 600,000 to over 1.7 million. For 2024, we started off the year just over 730,000 people living with dementia in Canada. And by the end of the year, we're looking over 770,000 with 145,000 new diagnoses or people experiencing dementia symptoms in the country. Call that annual incidence. Several factors drive this. The main factor, with age being the strongest risk factor, it's the aging of the population. So that as the baby boomers get into their late 70s and 80s and 90s, over this 30-year time period, that really drives up a lot of the numbers that we're projecting. We also account for evolving immigration patterns, and you'll see some of that in some of my later slides. But we've also accounted for changes in population level risk. If we actually standardize for age, we've actually seen better outcomes for individuals as they get older. We have better heart health care, less smoking, better education. So we're actually seeing a reduction in dementia risk or dementia status across the population. But because we have so many older adults, still going to drive those numbers up. This is just a model. It's not a crystal ball. We don't really know exactly what's going to happen. How will risk factor levels change over 30 years? Things like diabetes, heart health. How will those impact and change over time? We don't know if we'll have a new treatment or pharmaceuticals or tonics to help address some of this dementia risk. We don't know how climate change will impact these numbers. We don't have anything about COVID-19 or the pandemic within the model itself. So we don't really know exactly how the future will play out. But what we do is take current trends and try to extend them out using this agent-based model to try to get a sense of how dementia will impact Canadians. Here in this figure kind of illustrates that growth that I mentioned previously, the 187% growth. So the dark blue bars are what we consider prevalence, or the number of people living with dementia in the country. So steadily increasing over that 30-year time period. And that's driven by the light blue bars, which is the annual incidence, or the number of new diagnoses that we can expect. And you can see by the 2040s, that annual incidence is almost doubling. It's going over 250,000 people developing dementia each and every year in Canada. That's the equivalent of over 21,000 per month, or about 700 per day, or 30 every hour. And if we were to add up all those new cases across that 30-year time period, over 6.3 million stories will be deeply impacted by dementia. And that's just the individuals themselves, not talking about all the family members that will also be impacted. That brings me to the second report, the Many Faces of Dementia in Canada. So with this rapidly increasing size of the dementia population, I really think it's important now to get a better sense of the diversity that we see within the country, within people living with dementia. So we've used the second report to literally and figuratively put a face to those numbers. It's really easy to get lost in statistics. I say 1.7 million, it just seems like a big number. That's 1.7 million individual Canadians who have stories, who have faces and had experiences and emotions that get impacted by this condition. So we really wanted to put, not just get lost in those numbers, but also literally put a face to it. So we've shared stories across the report of different people's experiences with dementia themselves or taking care of someone with dementia. We have 5 aims for the report. One, we want to increase awareness of this diversity, and I'll break some of that down within my report or within my presentation, but you'll see that within the report itself. So really highlight this idea of diversity in dementia. We want to improve the public's knowledge of dementia. I live and breathe dementia every day, but if you talk to the average person out there, they might not know much about what the condition is, what are the risk factors for it. So we want to use this to try to educate the public more generally. We also want to advocate for better dementia care for all people living in Canada, whether you live in the big smoke, as we call it, Toronto, or you live in Rainy River. Everyone needs to have good dementia care. We also want to create action to inclusion, equity, and diversity in dementia. And finally, push for change, more dollars for research, better care, better support systems, better programs to help people living with dementia. There are 4 main topics within the report. I'll cover each of them pretty briefly today in the presentation. We focus on Indigenous populations, differences across different racial groups, differences between sex and gender, and then finally a focus on young onset dementia. So to begin, we focus on dementia and Indigenous peoples. If we look at the Indigenous peoples in Canada, we have 3 main groups: First Nations, the Métis, and the Inuit. And in 2016, the census that informed the data on the model, over 2.1 million people reported Indigenous ancestry. Often when we think of these populations, we think of them as being younger. They are also aging as well. You have a growing number of Indigenous people over the age of 65. And with age as the strongest risk factor for dementia, we expect increases within Indigenous populations from coast to coast to coast. But we can't just focus on age. When we think about Indigenous people's health, we also have to recognize that there are social determinants of health, and one of those is being colonialism. We've borrowed this tree model from an Indigenous publication to really show this deep connections between the different factors beyond the individual that influence health outcomes. So you have colonialism at the root of many of these issues, but then you also have systems that can play a role. And often when we think about dementia and health, we think about those individual lifestyle factors that drive health outcomes, but really we all live in a context, and that context influences the resources that we have and many of our health outcomes. So this model really helps demonstrate or illustrate those connections that we have in terms of social determinants of health. So it's important for Indigenous populations, but also I think for all populations, recognizing that the context that we live in deeply influences our health outcomes. We also, in the chapter, highlight how chronic stress can affect brain health. There's a growing amount of research that looks at how stress experienced on a daily basis has an influence directly on the physiology of the brain, and across a lifetime, that chronic stress can have negative impact on cognitive health outcomes and dementia states. So here, when we look at Indigenous populations, we could think about experiencing everyday racism, but also stress from housing issues, socioeconomic issues, etc. So this is a growing kind of new area of research, but I think it's really important to recognize this impact of chronic stress on brain health. We also highlight how racism can be a barrier to care and also be a barrier to dementia care for Indigenous peoples. So we need to work to try to break this cycle of racism in the healthcare systems. At the end of the chapter, we concluded by highlighting some of the available Indigenous dementia resources that have been developed over the last few years. There have been new tools used for assessment, but also educational tools to help deal with the stigma that does exist within this population for dementia. So in terms of some of the numbers from the model, we look at what the model says. We see almost quadrupling of numbers from 2020 to 2050, so a 273% increase across that time period. Similar growth to what we see across the general population, but even a bit more. Again, we don't want to just focus on numbers, so we also embed stories of First Nations, Métis, and Inuit individuals within the report itself. I would also mention that these numbers are probably fairly conservative, because we do know using governmental data, they often do undercount Indigenous people across different cities and different regions. So we can actually think these numbers are probably underestimate of what we'll truly see over that time period. The third chapter is ethnic and racial diversity of people affected by dementia in Canada. When we look at the population of Canada, we're well known for being multicultural. Thinking back to that 2016 census, over 250 different ethnic origins were recorded. This diversity is widely considered as a fundamental Canadian value, and it's the result of many waves of immigrations over the past 50 years. I'm a gerontologist in background. We recognize that older adults are becoming more diverse, many different cultures, languages, but that diversity is also now reflected within people living with dementia as well. And you'll see some of those findings at the end of this section. If we look at studies from the US and the UK, they consistently report that there are differences across different racial and ethnic groups within those populations. Here in Canada, we haven't done much of that research. We often don't actually collect race-based data. We see a change in that growing recognition of that. That's important to collect that data so we can understand these differences and try to address them through research and policy and programs. The model itself was highly influenced by this American study by Maeda and colleagues out of Northern California, where they looked at 6 different ethnic groups, and they found that dementia rates varied widely, over 60% between these 6 different groups. So there are differences depending on which ethnic background you have. Why that is, it's a good question. I don't think we really understand it well. There are some ways that we can kind of think about it that might drive some of these numbers. I don't think there's a simple answer. There are potential disparities in rates of dementia risk factors. We know things like diabetes vary across the populations, and that can be driving some of these outcomes. But we also need to, again, recognize these social determinants of health and how they can negatively affect brain health, leading to differences in brain health or dementia outcomes in late life. There are also differences in genetic risk factors and biomarkers across ethnic groups. And also, people from racialized communities can receive poorer quality dementia care. When we look at dementia research overall, it's widely recognized now that diversity has been missing from many research studies. Often studies focus on well-educated white populations. So now we need to do a better job with it as researchers to try to have samples to reflect what we truly see across our population. And this is widely recognized, and there's lots of work trying to be done to change this. In terms of some of the findings from the model, these 2 pie charts represent the people living with dementia in 2020 and then 2050, broken down by these large kind of ethnic groupings. And the biggest shift that we're expected is in the population of people of Asian origin, growing from 8% in 2020 of people living with dementia to almost 25% or 1/4 by 2050. So a large increase in the number of people of Asian origin living with dementia in Canada. So hopefully our programs and policies and practices can reflect some of this changing, the changing landscape of dementia in Canada. This change is driven primarily by the difference in growth across these different population subgroups. Here, the top line, that's the Asian group, and almost 800% growth over that time period. Now, this isn't driven by higher risk in Asian populations. In fact, if you look at the data, they're actually at the lowest risk across many studies. So what's really drives it is age. Aging of the Asian population drives it. So over time, back in the 1970s and beyond, we saw shifts in immigration patterns within Canada. More people from Asian, Middle Eastern countries coming to the country, and that really is driving these higher increases in the Asian populations. So that's East Asian and South Asian. That's the best kind of groupings that we could have using the data that we have from the 2016 census. Again, don't want to just focus on numbers, so within the report, we've had stories of people's experiences either with dementia or caring for a loved one living with dementia. The next chapter focuses on sex and gender differences in dementia. If we look across high-income countries around the world, females outnumber males in dementia diagnoses at a rate approximately 2 to 1. So for every 3 people who have dementia, 2 of them are female. Factors related to both sex and gender can shape a person's dementia experience, all the way from before symptoms start and the risks through to the treatment and beyond. The table on the right, which you can find in the report, breaks down some characteristics by both sex and gender and how they can influence risk of developing dementia. Why do women develop dementia at such a higher rate? It's not me, is it? So the question is, why do women develop dementia at almost twice the rate according to men? Often it's attributed to the fact that women live longer than men. In Canada, women live 4 years longer than men, with age being the strongest risk factor for dementia. That does drive some of those findings, but if only it was as simple as that. There are many other factors that can consider when we're thinking about sex differences and gender differences in dementia. So here I just highlight some of these sex differences that drive dementia outcomes differently in men and women, but this is not a full list. There's many more factors. So if you look at data from around the world, you can control for those differences in age or longevity. And in some places, you see men and women actually have the same level of risk. Like for instance, in the US, you control for age differences, same level of risk between men and women. Go to UK, do the same kind of analyses, women are still at higher risk. What this tells me is that it's just complex, and there's many factors, include biology, but beyond biology into gender roles that can influence people's dementia experiences and dementia outcomes. Well, when it comes to looking at risk factors, like I mentioned, gender roles can play a role in that. So think things like education and occupation across the lifetime will influence your brain health and your brain health outcomes, like dementia. So recognizing that there are differences between men and women and that will influence risk is important to understand that and how they can influence dementia outcomes across populations. We also used the chapter to highlight some work by Elaine Wiersma at Lakehead University, looking at people's identity and how some women have reported that their gender identity is consumed by the dementia diagnosis. So no longer are they the grandmother taking care of their family, they become a person living with dementia, almost like a genderless being. So they have used research to kind of look at that and try to highlight the importance of recognizing people's identity and how it's important for all people as they get older to maintain that. You can also think about men and women and how they have different needs when it comes to caregiving and supporting people living with dementia. So we need to better recognize that and not use like a one-size-fits-all approach when supporting care partners. And there also is more research needed to try to better understand non-binary, intersex, and gender diverse people. We really don't know much about how dementia works across these populations either. On the right, I have a table that tries to cover how dementia treatment and progression differs across sex and gender. So here is a figure. The yellow bars are for females. You can see higher across the board from 2020 to 2050. And the stat to kind of remember is that by 2050, we expect over 1 million women to be living with dementia in Canada if the current trends prevail. The final chapter that within the report is young onset dementia, the distinct challenges that they face. So young onset dementia is a term that is used for when dementia symptoms occur under the age of 65. It's a relatively new term. It's replaced early onset dementia because early onset dementia can be confusing with the early stages of the disease. So we just kind of shifted to young onset. You might also see younger onset. This is a new term, but it's not a new phenomenon. In fact, the very first cases of Alzheimer's disease were both individuals in their 50s. So new term, but not a new phenomenon. People have been experiencing dementia earlier age 65 for a long time. But when it comes to young onset dementia, there are distinct challenges due to the time in the life course that they develop the condition. There are a range of different unique challenges. This could come from a wide variety of symptoms that occur for people with young onset dementia and a wide variety of causes of young onset dementia. There also is a lack of awareness among healthcare workers about the existence of young onset dementia, which can often lead to a later diagnosis within the disease trajectory. There's also different care needs because of the time in the life course where people develop symptoms, and they also have different circumstances. They might still be working in their career, might have young kids at home. So that this difference, there are many differences when someone experiences dementia at age 60 compared to age 80. Yet most research is focused on the older adults, and most care is set up for those older adults, leaving those who develop dementia at early ages with some detriment to those individuals. So here are some of the findings from the young onset. The numbers aren't as extreme as you see for some of the other chapters. Partly that's because when we look at the overall population, a lot of those numbers are driven by the age of the population. So you almost have what we call exponential growth. For the young onset, we still see growth, but it's a much smaller number compared to older adults developing dementia. But still, we're talking about tens of thousands of Canadians being impacted by the condition. Again, don't want to just focus on the numbers, so we should get to share stories of individuals who've experienced young onset dementia within their families. So in conclusion, I just want to highlight the fact that diversity in dementia doesn't stop at these topics that I talked about today. There are other aspects to consider that are important that have an influence on people living with dementia. So things like sexual orientation, that can have an influence on risk of dementia, the care that people receive, and the support that they get. We could also think about people with intellectual and developmental disabilities and some of the challenges that they face in terms of assessment of dementia and living circumstances and beyond. We can also think about our aging prison populations and how we're seeing more and more dementia within people living within prisons, and how do we best support those individuals living in the prisons and when they get released as well. We also see a growing amount of homelessness and substance abuse within our population, and how that is going to play in terms of our numbers and how we support these individuals. It's something that we need to better address. I like to say that we are all unique. We all have our own unique stories, but when we're trying to think about the population, we need to recognize that we have shared characteristics and shared differences that are important to look at when planning future supports. In the final section of the report, we have a bunch of recommendations to try to highlight some of the opportunities where we can optimize supports for the wide range of people who will experience dementia in the coming years. We can't really expect a cure or a pharmacological treatment in the near future, but there are a wide range of actions that we can do now to support individuals and to reduce the number of people developing dementia in Canada. So hopefully with some of this work, we can highlight these opportunities and work towards making things better for all Canadians. For the recommendations, I'm not going to go through each and every one of them. There's over 50 within there, broken down by these different chapters, but also by different lenses. From the Alzheimer's Society perspective, what can healthcare systems do? What can different levels of government do? And what can researchers do to try to address dementia across these different topics? But again, I just want to conclude that it's not just about these growing numbers. Each and every one of these numbers that we have in our projections are individual Canadians that will be impacted, and also their family members. So it's important to think about the impact that this will have on people over the next 30 years. And thank you so much for listening to me, and I think we have some time for questions.
Looking for a section on genetics. Where's genetics?
So the question is, you're looking for a section on genetics, and where does genetics come into it?
Ethnicity, race, diversity, long list here. Where's genetics?
So there's some genetics in the first report, breaking it down. So there are different ways. It's a big conversation, but ApoE, we all know about ApoE, that impacts people's risk of developing dementia, but it's not deterministic. But there are certain genes that do determine whether you have dementia or not. And then there's a growing understanding of different other genetics that can influence dementia outcomes. So there is some understanding. So there's genes that can impact your risk, but then there's genes that can almost, if you have certain genes, you're going to develop dementia. And those genes run in families, and that's where you get more of what's called familial Alzheimer's disease. So that's going to happen usually in a large number of people within the same family and at younger ages, but that's fairly rare. ApoE is something to learn about. You might have seen Chris Helms, is that his name, the actor? Recently found out he had E4 alleles within himself, which puts him at higher risk compared to many others. So he's learned that and now trying to address his risk through adapting his lifestyle to try to lower his chance of developing dementia as he gets older. So hopefully that's answers your questions. I'm happy to talk afterwards more about genetics, but really what we understand about dementia, it's partly driven by the genetics, but a lot of it is driven by your lifestyle and your context that you live on. So that primarily drives it more than genetics does. Yeah. So the question is for the people online who can't hear, questions about cannabis and is there any research looking at outcomes related to dementia and vaping? There's not a ton. I think it's pretty early days. It's not an easy thing to study. When you look at cannabis, there's different types of cannabis, different strains, different ways to ingest it, different frequency of use. Don't really have a good understanding. Some studies show actually positive outcomes, some show negative. If it is impacting the lungs, obviously it's going to have a negative impact on the overall body. But yeah, I think it's too early to really know exactly how that's going to play. I get this question fairly regularly, especially as a greater number of older adults consuming cannabis as well. But it's a great question. I don't have a solid answer for you, but I think lots of work can be done to try to better understand the impact of that. In terms of vaping, I don't know much research around like vaping tobacco. Is that what you're asking about, or? Yeah, I don't know much around vaping, but I can say that like anything that negatively impacts your brain is going to be worse for your dementia risk. So the more things we can do to protect our brain, the better that we will be. Yeah. So in the first report, the question is, are there any differences across Canada in terms of dementia risk? So there is breakdown. We don't actually calculate risks across different populations within Canada. We do break down by provinces. We see the greatest growth in Ontario, Quebec, Alberta, and BC. That's primarily driven by the large size of the aging population. If you look at the East Coast, they're already actually they're older population. At least they were when we did the modeling. We saw a lot of migration to the East Coast, so that might change some findings. But because they're already an older population, they actually peak a bit earlier than 2050, and their numbers actually start to improve because the population gets a bit younger. But there are studies that look at not so much dementia rates, but dementia risk factors across Canada. So if we can better understand our populations and look at the risk factors for dementia, each of them, I think that's where we can better address dementia outcomes by trying to tackle those risk factors where they're higher across different regions. So some regions might have higher levels of smoking, higher levels of alcohol abuse, more physical inactivity. If we can try to take a kind of an evidence approach and address the challenges that we see across each individual population, I think we'd be better off to try to reduce some of these trends that I highlighted in the projections. Yes. Sorry, what was the last part of the question? It's a good question. I don't really know. So the question is about how do we compare it to Japan and other countries that experience dementia. I don't fully know cross-country comparisons. It's really hard to actually capture the number of people who live with dementia in a country. I thought it'd be simple until I got this job and tried to figure it out for myself, and it's not simple. There's definitely a challenge of dementia in the Japanese population with age being the strongest risk factor, but you might think that some that they have and also some of their culture might have a positive impact on their brain health. So things like fish and soy consumption, but also family dynamics and staying closer to family and having social groups would have a positive impact. So I'm sure that's true. I just haven't looked at the data and I can't really speak to it too much. But great question. Yeah. So the question is about nutrition. There's some of that's kind of calculated within the model using broad statistics, but we don't really dive deep into it. Similar to cannabis, nutrition is very hard to study. It's so complex to kind of capture that. To try to ask someone what they ate over like, what did you eat in the last 7 days? And if you to fill that out, and then I have to try to take that from each one of you and try to figure out a trend, it's not going to be an easy task, but it's something that I think is important to get a better handle on. So there is good research on different kind of dietary patterns, you might call it. So like Mediterranean eating and different more heart health related diets are definitely shown to have positive outcomes on brain health and dementia risk in later life. So yeah, definitely important, but not easy to study. But like I said earlier, anything you can do to improve your brain, it's going to lead to lowering your risk of developing dementia as you get older. And brain health and heart health are deeply linked, so things that are good for your heart are also good for your brain. Important to focus on it as you get older. But even as you're young too, it's also, you can never start too early when it comes to your brain health. Yep. More than what? More than genetics? So the question is, what is the importance of social factors, and then in comparison to genetics? I'm not sure if it's good to compare the two, right? Because the genetics, you can't really do anything about them. Like you can't really change who your parents are. We're kind of stuck with that. We often break down risk factors for dementia by non-modifiable things. So you can't change your parents. You can't change what sex you're born with. What was the third one? And you can't change, we don't have a time machine yet, so we can't really impact our chronological age. But there are a growing list of factors that we know that are modifiable that can affect your dementia risk. And there's a growing understanding of the impact of social isolation, how that negatively influences brain health. Some people are even saying things like loneliness is the new smoking. It has a hugely negative impact on your brain, but also your whole body. We are social creatures and we need to be networked to whatever level. We're all different. Some of us like to be more alone and be more independent, and others need to be extrovert and need the connection all the time. So, but no matter where you fit in that spectrum, it's important to be connected to your community. And I think there's a growing recognition of that, and we're trying to do more to try to help people stay connected as they get older, so you don't end up living at home with no social network, no family to interact with. That's super important to try to address from just a life satisfaction perspective, but also in terms of the brain health as well. Any further questions? Oh, one more. Sure. So the question is about the impact of alcohol on dementia risk. It's a good question. If you look at most research, what is it? It has what is called a J-shaped curve. So those who don't consume alcohol actually have a bit higher risk. Those who have moderate alcohol use actually has lower risk, and then it increases. So there's reasons to kind of explain why people who don't drink have higher risk. Sometimes they could be sick or ill, and that raises the risk. But really what most of the research shows, it's not negative to have 1 or 2 drinks. It's those who abuse alcohol. That's where you have the greatest impact on your brain health. So we have seen some literature come out more recently with like very negative about alcohol and showing impact, but if that more recent report actually never talked about dementia outcomes, so it's cancer outcomes. But in terms of looking at dementia, it's you see negative outcomes is when you abuse alcohol at a heavy rate. So going, I'm not sure, like over 6 drinks a day, that's going to be negative. That's where you see the bad outcomes. Those who have moderate alcohol consumption, usually at low risk. Yeah. So sorry, so I can't. So I'm not a clinician. I'm not sure exactly how to help individuals in that state. There is conditions where if you're just drinking too much alcohol, you can get into a state that's like dementia. But once you've reduced that alcohol intake, you can actually come out of that state and regain your cognition. Someone that's with dementia and maybe drinking too much, it's a tricky thing to do, I think, because if you take alcohol away from someone that's been drinking it for years on time, their body's going to have a negative reaction to that, and that might cause health issues as well. So you'd probably have to figure out how to tailor it off or have behavioral supports. I don't have the answers, but maybe someone from the Alzheimer Society might be able to help find those answers for you. Thank you guys so much for your time today. I'm happy to see you guys and happy to chat after the session's over. Thank you.
Exceptional, Dr. Armstrong, particularly while standing as the sun sets over the west of Windsor. Thank you so much for your support. It's my great pleasure to introduce our local University of Windsor researchers, Dr. Siyaram Pandey and Ms. Keanna Dube.
Thank you. All right, we are getting set up for the next one. And as already described previously, very nicely, the stats and scary stats coming in the future. That's good. Thank you. So I myself is a cell biologist and biochemist, and we have been trying to see at a cellular level what happens in the brain, why these wonderful neurons decide to die, and why to prevent that. I will be going in that direction. Before I go ahead with my presentation, I would like to acknowledge the wonderful generosity of this community. You might see a picture of Mr. Joseph Sachi. He's no more. He was Parkinson's patient. When he came to know about some of our work in neurodegeneration, he generously donated $150,000 to the research project, and that really touched our heart, and he's always there. We dedicate our work in his memory. And then this project was also funded by CIHR in the earlier stage and Michael J. Fox Foundation. The formulation we are going to talk about is owned and patented by NRC and given to Next Remedies. And again, before I go ahead, I would like to acknowledge and remember my collaborators, Dr. Mariana Sikorska, who was my group leader in Ottawa National Research Council. That is where we developed a water-soluble formulation of CoQ10. And she is retired, unfortunately stuck with a stroke at home, recovering. And most importantly, our collaborator and colleague, Dr. Jerome Cohen, as Shelley mentioned, he's the behavioral collaborator, and he is also recovering at this time in ICU, hopefully. And with that, let us go ahead. Brain is made out of, they don't have exact number. Some people say 6 billion neurons, and some people say anywhere between 6 and 10. But whatever it is far less than the debt we have in Canada. So basically, these are long-lasting post-mitotic cells which make up our brain by networking, and one of the most fascinating living systems. And since we live with whatever neurons we are born with. We don't get, these cells don't replicate, don't regenerate. We have to really take care of them. Now, not only that they live very long, they consume 10 times more oxygen than the other cells in the body. Oxygen is very nice, it gives lots of energy, but as a chemist, I find most toxic compound is oxygen. If it is not fully reduced, it makes oxyradicals, which causes oxidative stress. So when oxygen is used by the brain at the rate 10 times higher than the other tissues, it produces oxyradicals. It has a very good antioxidant system to cope with it. However, unfortunately, in the cases of Alzheimer's or Parkinson's and so, where these antioxidative mechanisms are not good enough, and the cells start feeling oxidative stress. That is one of the factors as we age, as mentioned by previous speaker. Age is one of the highest risk factor. And as we age, we all feel that our oxidative stress level keeps increasing and increasing. So that is the one. And there are some other very important factors other than oxygen. These neurons, they talk to each other, they have fantastic cleaning system. We know that if some cells live for a very long time, there will be damaged protein, damaged mitochondria. So if they accumulate, that will create a problem. So they have fantastic cleaning system called autophagy. So these cells manage to take this bad protein, bad mitochondrial organelles and digest them out and recycle them. So cells remain good in health. And as we go along, particularly in neurodegenerative diseases, there is inhibition of autophagy. It goes down. And that leads to accumulation of the bad proteins. That is also a risk factor. Then another risk factor, inflammation. You might have listened to radio program, others people talk about Alzheimer's might be because of infection in the brain and immune response to infection and so on. But bottom line, inflammation is also one of the etiology of Alzheimer's. As I was sharing a joke with in the previous lecture, my friend who is a neurologist, he did MD, PhD, we did PhD together, so we always talk. So I was telling him that I was diagnosed with osteoarthritis recently in my knee. And he says, congratulations. I said, why? He said, your knee might be bad, you have some trouble, but brain might feel good. I said, why? Brain is in pain. He said, you will be taking now anti-inflammatory drug forever. And that might reduce the risk of inflammation in the brain. I thought it's just a joke. I just checked in. There are a couple of studies already being done with the risk of dementia and use of anti-inflammatory drugs. That brings down to, once we have all these risk factors, what can we do to prevent these risk factors? And once we are diagnosed with the disease, what can we do to halt the progression of the disease? Okay, coming back to this bad is that, I'm not going to go into that. Everybody knows the symptoms. It is not the mortality, it is the morbidity which is problem. We are human beings and we have all our emotion, everything, because we have hard drive, which is unique to us. If that loses it, we get into lots of trouble. And not only one person. I was telling, whatever number you gave, multiply that by 2, because his spouse is the first person affected by the disease. And then I believe on an average 4 people. So it is no doubt difficult disease to deal with. There are deposition of amyloid plaques and neurofibrillary tangles. The sad part is that it has been for a very long time. People have been working very hard to look for some therapeutics. Every 4 years there is an International Alzheimer's meeting, and we look forward to any news coming from that, some clinical trials, some news, and every year it has been kind of disappointing. So far, we only have symptomatic relief with whatever is the esterase inhibitors and so on, whatever we give. Recently, a couple of years before 22, 23, biological interventions, which is the monoclonal antibodies against amyloid beta, were approved for treatment, but they target only amyloid beta deposition. And there is some indication they can slow down. But honestly speaking, there is nothing today to, once the person is diagnosed, what can we do to stop the progression? And as I was mentioning before, it is like a child walking towards ditch or well. And we know it is very dangerous. Everybody wants to save the child, but we are so helpless. So we are trying to focus on two things. One thing is try to work on intervention to block cell death and neurodegeneration. So the halt the progression, number one. Number two, what kind of interference we want? Can we target a particular enzyme using a chemical or pharmaceutical compound? By and large, we know that whatever pharmaceutical we use, it targets one, it may have other side targets too. But no doubt, pharmaceuticals have been very effective in treating many diseases, including chronic diseases. However, there's a trouble. We get a treatment for 1 week for antibiotics, for bacterial infection, or 2 weeks, 3 weeks, it's okay. These neurodegenerative disorders are not weeks and months. They are years and years and years. So whatever formulation we come up, which can halt the progression, it got to be of nutraceutical category. What I mean, it should be well tolerated so that it can be consumed over a long period without side effect. And that is where we think that some of the natural extract have that capability. Sorry. Hello? Sorry, I am in a meeting. You can go home. It's fine. This was somebody who's trying to go home. PSW, by the way. Okay, so now we do think that there is some hope and what we have started working with. Now coming to this hypothesis of etiology, as I said, inflammation, oxidative stress, and I forgot about mitochondria. Brain cells use lots of mitochondria, particularly during the signal transduction or during the action potential in the synapses. Huge amount of mitochondria are energy factory, and they are like nuclear plants. If they are not leaking, you get lots of energy, good. If they leak, you are doomed. So mitochondrial health is extremely important. So mitochondrial dysfunction, oxidative stress, inflammation, accumulation of the bad proteins, inhibition of cleaning system, and inflammation, as I mentioned, and synaptic health. These are the 5-6 biochemical etiologies which lead to neurodegeneration. Now, if we target any one of them, we may not be very successful, as is the case with amyloid beta targeting by the antibody. Because maybe you can block the accumulation of amyloid beta, cells might be feeling other toxicity like oxidative stress still. So we thought of targeting all these using simple nutraceutical kind of compound. And with that, our aim today to discuss is, first thing, to develop better non-invasive diagnosis system. Actually, we are very excited to report that we started this project just a year ago or before, looking at literature here and there. MRI is a technique where brain scan can be done very safely. And if there is any indication that something is growing along with the disease progression. So we started that project, and you will be shared with a very nice result today. And not only just following the progression, but if we are using neuroprotective agent as a therapeutics, we can follow the effect of that treatment using that technique. So structural changes in the brain, which happens during the progression of the disease, if they can be blocked by our therapeutic which is being developed. So we can use that technique. That was the whole purpose we tried to establish that. And then second objective is to develop therapeutic regimen that can halt the progression, and therapeutic regimen which is safe to be taken over a long period of time. And that is where we require this collaborative effort. So we work with mice and rat, for example. As a biochemist, cell biologist, I have my skills limited to the microscope and biochemical staining. I really can't do behavioral tests. Dr. Cohen is our behavioral psychologist, and he's the one with whom I collaborated this project. And his group can talk to mice and rats, apparently, in a different way, and ask them, do you remember or not? So behavioral collaboration on the other side. And for MRI, I have zero knowledge. So is Dr. Cohen. That is where we collaborated with Dr. Zhao, who is in Department of Physics, and her expertise is in MRI. So all three of us came together. We wanted to get this machine. I really want to thank Faculty of Science to fund this machine. Also, Dr. Cohen personally donated to that MRI machine for the mice. So with that, we launched on this. Little bit background, coenzyme Q10 is one of the key factors in our respiration in the mitochondria. And our hypothesis was coenzyme Q10 acts as an antioxidant. It can accept electron, it can give electron. So because of that, it can reduce oxidative stress, number one. Number two, if you put a little bit more CoQ10, the mitochondrial output might be a little bit better, more energy. And the third thing is, we thought, since it is lipid soluble, binds to membrane, it may stabilize the mitochondria. So at that time in NRC, Dr. Sikorska, my supervisor, thought, so we started doing the experiment with the cells with CoQ10. However, whatever CoQ10 available in the market, you put into the Petri dishes and it floats on the top. It is totally water insoluble. We couldn't do nothing. And that gave the idea, why not we solubilize that? And Dr. Sikorska hired a chemist and Dr. Sibrowski, and he managed to solubilize it, combining with vitamin E and polyethylene glycol, which is called micellar formulation, which would be, this is the mitochondria, and we believe CoQ10 can prevent permeabilization. That's all you need to know. This is our formulation, which is really water soluble, and somehow the cells just loved this formulation. The moment you put them there, they keep taking lots of CoQ10, and they become very robust. I'm going to share some of the in vitro results with you. So the first objective was to test this water-soluble coenzyme Q10 in its efficacy to inhibit oxidative stress or inhibit glutamate toxicity, using in vitro culture where we grow the neurons, basically. And these are the cells treated with hydrogen peroxide. This is only in the Petri dishes. We don't do anything to people like that. So artificially, we induced oxidative stress. And if I go, do you see movie there? These are dying neurons because of oxidative stress. Then what we did, we pre-incubated the neurons with CoQ10, is water soluble, and then did the same thing, challenged them with oxidative stress. Do you see movie? Many people may see this is a still picture. It is the 24, 48-hour timeless photography, as if nothing happened to these cells. I keep showing it, it's very old result, because this was our kind of enlightenment moment. Oh God, this material can prevent oxidative stress-induced cell death close to 100%. That's why we got excited. And of course, I will show you the still picture. You see, this is glutamate excitotoxicity. The panel over here is unprotected, the first one. Second one is protected, and you can see the day and night difference. These are differentiated NT2 neurons. Then we did another experiment. I don't know, can you see red dots? I really can't. You can see it? Okay, there's too much light. You can see either sun or the red light. Okay. So we stain the cells with mitochondria sensitive dye and challenge the cells to oxidative stress. And we do feel that, did see that mitochondria will depolarizing. Okay. However, if you do the same treatment with CoQ10, they were not breaking down. They were stabilized. So this was also an important clue that this formulation can stabilize the mitochondria, which is what we want. All that is good in the Petri dishes. Whether it will work in animal system or not. We can't do anything in human. We are not clinical researchers. As a preclinical researchers, or doctorate degree as a PhD, which doesn't do anything to patient, only to the vitro and in vivo result. So that is the big question. So for that, we chose transgenic mice. These are the mice where mutated human genes were introduced. These mice we can buy commercially, and over the time, they develop amyloid plaques and behavioral deficit. This is well established. So we thought we can use the same model, mice, give half of the mice our CoQ10, other half just water, and have a same number of mice, healthy mice, without any defective genes, these three groups, and follow them up if there is any protection, okay? So I am going to share the result with double transgenic mice with only 2 mutations, presenilin 1 and APP. And Keanna is going to take over, and her recent experiment is with 5 mutations, 5 XAD mice, and the same result as we do. Of course, she has the MRI result along with. Hello. So before we just, it's a babysitting. Each Alzheimer's disease experiment with mice takes anywhere between 12 or 15 months to 18 months. Mice live for around 2 years, and this is age-related disease. So we just bring them on. One group is put on the CoQ10 feeding tube, which has in the water. Other one is just water. And we keep monitoring their memory. That's what these guys can do, the behavioral people, how good they are. This is the one result I'm going to share, which is again spatial memory, long-term memory, in which the animal is given a space or some of the Y image to familiarize and one object in one of the arms. And after 15 days gap, they are given the same maze again. So if memory is intact, the animal will not be interested in getting in the arm. The same thing, if he's good in memory. But if memory is gone, then that mice might find it still a new thing, so he might make more entries. So this is what we tested at the end, and we do see here the first 2 things. One is wild type, healthy mice, not big changes before and after, because he knows it's the same thing. And the last 2 columns where one is high, that is the Alzheimer's disease mice, without any treatment, no protection. That mice goes more entry in the maze because he cannot figure it out, it is the same. Whereas the treatment, or treated group of mice, 6 of them, they behave, the middle one, same as wild type. So that was very interesting. This work is old, it's already published, and you will be shared with our new results very soon. So that was interesting. While in mice we were saying the memory, we also took some blood from each mice and measured the amount of amyloid beta circulating in the blood. You can see the control, transgenic mice, AD mice, the amount is higher, and treated mice, this halfway through. It was lower, halfway through, half. And of course, wild type didn't have any. So that was another indication this treatment is doing something. Now the next important, after behavior is done, whether this behavior correlates in the brain with a staining. Is there a amyloid plaque in the brain? Indeed, it is. So first column, untreated, there are red dots there. The second one is treated with our formulation. You can see very few of them. And the last one is healthy one. Actually, it was too good to be true, as reviewers said. They said, you have to use another stain to prove it. So we did this immunostain, and indeed we find more than 80% inhibition of plaques in the brain of the mice with this treatment. So that was quite interesting. Now, this is something later we did with the same brain. I told you a phenomena called autophagy, cleaning system. This particular staining In the wild type, the first columns, they indicate that these healthy mice have a lot of those brown cells, indicating healthy autophagy, cleaning system. We do see in AAD mice, Alzheimer's disease mice, it is going down. It is not there. Not only that, we had a placebo treatment, PTS, only the solvent, that also did not show any. However, CoQ10 feeding led to activation of autophagy. We are very excited about this result. That using this simple nutraceutical, giving orally, through the system it goes and fixes the brain. Basically, it activates the cleaning system. We have confirmed this again and again because this is very important. And this might be very important in development of therapeutics. So this is the conclusion. Compared to oil-soluble formulation, our water-soluble formulation, you don't have to take very large amount. It is 100 times lower, and it shows very good efficacy in halting the disease progression, as we saw. Not only that, if we had money, we could have done preventative study right from the beginning, and I'm sure it would be used as that as well. Now, in 2012, a major research paper published from McGill and Indian Institute of Science about ashwagandha extract. Ashwagandha is Withenia somnifera, is the name of the plant. Root of this plant, also called Indian ginseng, some people call it. They have been used in Ayurvedic literature as a brain tonic and so on. So these two groups joined together, and in the same transgenic mice model I had before, they showed that this extract from this root was very effective in reducing the plaque and improving the behavior. So we argued, why not use that and combine that with CoQ10, two good things together. Number one. Number two, the ashwagandha extract used by those researchers were at a very high dose. It was 1 gram per kg per day. And the extract was made using chloroform, ethyl acetate, a chemical extraction. We argued that let us isolate or extract it simply using 100% ethanol. Any extract you prepare, either using water or ethanol, they are called biocompatible solvent. Those are in the category of natural health product or food supplement. It's easy to get approval later on. So we made our own extract and combined that with CoQ10, and this combination we call them tonic. Again, this ashwagandha has many phytochemicals. One of the advantages of natural extract is scientifically disadvantage because there are many compounds we don't know who is doing what, but physiologically advantageous. There are multiple compounds and they can target multiple targets. So we might get better effect. Remember, we are looking for 5 targets: inflammation, oxidative stress, mitochondria, autophagy, inflammation, everything. So maybe that is the advantage. Second thing, extract as such is in the category of nutraceutical or natural food supplement. If you purify one compound, that becomes pharmaceutical compound. That becomes difficult to get approval or to be used for long period. So again, I can't see because of too much light here, but I just wanted to show that indeed the simple looking at the lipid peroxidation basically and autophagy basically in the cells, basically fibroblast. These are the cells taken from the skin of the Alzheimer's patient basically. They have donated it and they have made a cell line. In those cell line, we did see that treating them with tonic reduces oxidative stress and induces autophagy in the skin cells. Well, that is good, but it's not good. We are working with neurons. Then we started working with those tissues from those double transgenic mice, which have been treated and untreated. And again, we gave the same treatment. And here we see very clearly the inflammatory response which happens in this one. There is inflammation along with the plaque. And that inflammation is brought down to some extent by CoQ10, greater strength by ashwagandha, but tonic was the best one. So we did see that combined effect was much better than individual one. And here again, the beta amyloid toxicity, a simple, the accumulation of oxidative stress and beta amyloid, that also was reduced significantly. And this one is kind of protective response. And this leads to, whenever we get any injury or something, there are two kinds of glial cells, microglia, astroglia. Astroglia, we think they are good ones. They try to secrete neurotropic factors, protect the neurons. They try to decrease the oxidative stress too. Microglia, on the other hand, are inflammatory glial cells. When they are activated, they produce inflammation. So this is the protective response. We did see activation of astroglia in the tonic treated or individual treated too. And here we did see an increase in BDNF production in the brain area. BDNF is one of the neurotropic factors which helps neuron to survive. And this one is a recent result where we look for synapses. I told you synapses are very important, where the neurons talk to each other. And it has been found that despite not huge neuronal cell death, there is dementia because of the degeneration of synapses. So ashwagandha has been shown to improve synaptic health. So we look for some synapsis markers. We did see an increase in one of the protein related to synapse formation. And that is something, again, we are very excited about. This combined treatment can lead to decrease of inflammation, decrease of oxidative stress, synaptic regeneration, fantastic. Autophagy activation, even better. And the same thing I was talking about, the autophagy activation leads to cleaning procedure activated. Again, in the tonic, it was very obvious. With that, this is the summary of our older experiment. And at this stage, we thought we will include the MRI experiment to look for a structural change, as well as choose what you call it, most stringent model, this 5XAD model, FAD model. There were 5 mutations are there. So challenge yourself. If this tonic can protect against 5 mutated genes in the mice, that is the new experiment we started. We got a MITOX grant approved for it as well. But the next remedies, which makes this CoQ10 formulation, they did not pay their share. So we did not get the grant. And already Keanna was recruited, another person was recruited, so we were kind of in trouble. But Faculty of Science pitched in some money, and that's why you have a pledge form in your box here. We are trying to support these young people. And before I go to transfer it over to Keanna, she is a doctoral candidate, and there are other masters and undergraduate students. I must acknowledge their contribution. These are the people who work very hard. In behavior lab, they keep talking to these mice forever without any proper conversation. They keep monitoring them. And we don't pay them much. I don't want to disclose that. People will complain for the misuse of the workforce. $2.99 per hour, sorry. So they work very hard out of their passion and out of their motivation for this work. And we have just completed the first and second phase of this new model. And Keanna is going to share that result with you. Keanna?
Thank you. So before I begin, my name is Keanna. I am a PhD candidate at the university here, and I am so lucky to be supervised by 3 professors. So I have Dr. Pandey, of course, in biochemistry, and Dr. Zhao in physics. And I also am supervised by Dr. Cohen, who unfortunately cannot be here today. But if he were here today, he would be so impressed with everyone here today in support of our research. And yeah, he would be so thrilled. So I'm taking his place today. Hopefully I do justice, but anyways. So I am, as Dr. Pandey put it, I am the mouse speaker. And as a little bit of background to our mice and our current project, Alzheimer's disease targets the temporal lobe of the brain, which involves the hippocampus and the amygdala. Now, these two parts of the brain, they're closely related, and they're very important for encoding spatial memory. So when somebody is affected by Alzheimer's disease, one of their first symptoms is problems with spatial memory. Then as the disease progresses and the degeneration spreads to surrounding tissues in the brain, then non-spatial memory starts to become affected. So when the neurons get sick, they start to have issues communicating between each other. And therefore, when they can't communicate with each other, they die off. And this causes the brain to shrink. So when the temporal lobe is targeted, the neuronal density within that region starts to deteriorate, and the ventricles then get enlarged, and finally the cerebral cortex then shrinks as well. So the problem that has been repeated many times tonight, unfortunately, is that there is no cure. And current pharmaceuticals tend to alleviate the symptoms of the disease and can cause harmful side effects and toxicity with long-term use. So we've also found that perhaps preclinical and clinical trials assessing the efficacy of novel treatments may have failed because research tends to target just one aspect of Alzheimer's disease or one scientific discipline of it. So they kind of neglect the bigger picture of it, or not purposely, but in a way. So our solution to this problem is to introduce a novel nutraceutical treatment option using a combination of water-soluble coenzyme Q10 and ethanolic ashwagandha extract to hopefully halt the progression of Alzheimer's disease. And the good news is that humans have already been taking both of these for a long time, and it seems that they are well tolerated over the long term. And we are going to be assessing the efficacy of this treatment specifically to treat Alzheimer's disease using a longitudinal experimental design that follows the lifetime of the disease. And we are going to be collaborating with multiple departments within the university to look at the entire picture and what is really going on here. How is this treatment actually affecting the disease? So Dr. Pandey already did an excellent job of summarizing our treatment, but to simplify it, Ubizol Q10, or water-soluble coenzyme Q10, it does an excellent job of healing the mitochondria and therefore preventing the neurodegeneration and hence protecting the brain structure from deteriorating. Whereas ashwagandha is very effective at healing the communication between neurons. So both of these in combination complement each other very well. And we hope that these can target multiple of the 5 etiologies that Dr. Pandey had mentioned earlier. So to test this efficacy, we are going to be using 24 female mice, 16 of which are transgenic, so they're genetically engineered to express human genes associated with Alzheimer's disease. And we're going to be taking half of those sick mice and giving them our combination treatment in their water bottles. And we're going to take the other half of the sick mice and give them nothing, just water. And of course, we need to compare these two groups to an unmanipulated group. So that is our wild type untreated group. And then we will take all 24 mice and we are going to subject them to 3 repetitions of MRI, neurostructural imaging, and behavioral memory testing at 3 different time points in their lives. So at the mild degenerative stage is phase 1, phase 2 is moderate, and phase 3 is severe. So with this, we predict that the wild type mice, of course, are going to be healthy throughout their life. And if the treatment is effective, then the treated transgenic group should remain comparable to these healthy mice. And whereas the untreated transgenic group will progressively deteriorate, which is typical of this mouse model. So here's our MRI. It is very exciting. We are the first people at the university to be MRI imaging our animals. And I believe, Dr. Pandey, what did you say, in Southern Ontario as well? Yeah, so that's exciting news. So this is our MRI. It looks a little bit like a mini fridge, and it's about the same size, and it has a little drawer that you can pull out, and you put the mouse in the bed, then put it back in and take the pictures. But yeah, I've included a little picture of our mouse as well, all wrapped up in a blanket there when we're bringing her out of anesthesia. I just think it's so cute. We like to keep them nice and cozy when they're waking up. So what I love most about MRI is, yes, it tells us a lot about the structure of their brain and how that may change, but also it tells us a lot about the composition of the tissues within the brain. So we acquire the image using a T2 weighted imaging sequence, which basically, if you can see the picture, all of the bright spots in the brain are tissues with high water content. So that is cerebral spinal fluid or inflammation within the brain. So focusing on just the brain there, we can segment out those parts of the brain that have the intense brightness. And that can give us a volume of how much cerebral spinal fluid is in their brain, or how much inflammation is in their brain. And of course, we want to compare this to how they perform on our memory tests. So to do that, we use a 4-arm plus maze, and we put the mouse in the center of it, and we just watch it explore. We don't want to force the mouse to do anything. We just want to see how it naturally behaves in this environment. And the mice love it, which is great. It's not stressful at all for them, and they love the little objects and the treats they get in there. So if they're happy, I'm happy. So basically what we do is we set up the 4-arm maze with 3 objects in 3 of the arms, and we keep those objects there in these exact locations for repeated sessions of exposing the mouse to this maze. And basically, we want to habituate the mouse to these objects in these specific locations and have the mouse really get a good memory for these objects and how they are and where they are. Then, to test their spatial memory, we will take one of those objects and we'll move it to a new arm, to a new location. And the idea with this is that if the mouse's hippocampus is still functioning properly, if their spatial memory is intact, then they should recognize this change in their environment and have an increase in exploration of this object in the new location. Then to test their non-spatial memory, we take one of the previously unchanged objects and we swap it out for a new object that the mouse has never seen before. And with this, the same idea carries forward. So if their non-spatial memory is intact, then we would expect that they'd notice this new object and they would have an increase in exploration of the object. Now for my favorite part, the preliminary results. So we've currently undergone the first 2 phases of experimentation, so the mild and the moderate stages. And this is the results from the MRI, and this is so exciting. So we can see that in the first phase, both the treated and untreated transgenic group had significantly higher cerebral spinal fluid volumes within their brain compared to the wild type mouse, with untreated having the highest. Then, when we move to the moderate degenerative stage, this changes. So we can see now that the treated transgenic and the wild type mice are now comparable to one another, whereas the untreated transgenic group now has a significantly higher cerebral spinal fluid volume within their brain compared to both groups. So comparing between phases, we can see how their inflammation has changed within their brain over these time periods. So with the treated transgenic, you can see that they've had a decrease in their inflammation within their brain, whereas the untreated have increased and the wild type have mainly remained the same. So this is very exciting for us, but we want to see now how this relates to their performance on these memory tests. So to begin, we're looking at the spatial memory test. In both phase 1 and phase 2, you can see that all groups did have a increase in their exploration of the manipulated object compared to the previous habituation trial. But when you compare between phases, you can see an interesting trend start to form. So here you can see that the treated transgenic and the wild type mice have now increased in their performance on this spatial memory task, whereas the untreated transgenic group have decreased. So this could indicate that the untreated transgenic have had their hippocampus affected at this time point. And this is causing them to decrease in their spatial memory performance, whereas the treated transgenic have had their spatial memory mostly preserved, or hopefully preserved. Now for the non-spatial memory, we can see that in phase 1 and phase 2 and between phases, there's not a whole lot of difference going on between these groups, but this is what is expected because again, we are just at that moderate degenerative stage. So like I said before, when the hippocampus is affected, your spatial memory is one of the first symptoms. And later on, when the degeneration spreads to surrounding tissues, then the non-spatial memory is affected. So this indicates that their non-spatial memory is still intact, which leads us to our future directions. Phase 3, we are currently accumulating data for phase 3 right now. Today, we actually did our second week of the behavioral memory tests for this phase, and we are so excited to see how those results turn out, considering that the first 2 phases have been incredible. So after that, we then will do what Dr. Pandey is such an expert in. We will be staining their brains to see how those biochemical mechanisms have been preserved or not preserved. And this validates everything that we found pre-mortem. So then eventually we want to repeat this study with a set of male mice, because as Dr. Armstrong put so nicely, there are many differences between males and females in the way that they degenerate or the way that they respond to treatment. So this will help us develop a strategic plan of treatment specific to individuals. And in conclusion, to wrap everything up, our preliminary results have showed that through MRI analysis, the treated transgenic mice have had a decrease in their inflammation, which could indicate that this treatment is preserving their neurostructure and the composition of their tissues within their brain. And this relates to the cognitive memory test because the treated transgenic mice have had an increase in their performance of their spatial memory test comparable to the wild type mice, whereas the untreated have showed a decline. Now, with these preliminary results, our expectation that Ubezol Q10 and ashwagandha extract in combination to halt the progression of Alzheimer's disease has been extremely supported through this. So we are very excited to see where phase 3 takes us, and hopefully maybe next year we can present those. So in all, I would also just like to say a thank you in memory of Mr. Sashi for his generous donation towards our project, because we really wouldn't be here without him. And I'd like to say, again, some acknowledgements to our team behind the scenes. It's not just me and Dr. Pandey. We have a whole village that helps us collect this data. So yes, and I would also like to say a special acknowledgement to Dr. Cohen and his late wife, the beautiful Anne Cohen, who it is because of them that we have been incorporated into this wonderful community of Alzheimer's Society and accepted as family. So thank you for all of that. And at this time, I'd like to invite Dr. Pandey back up to answer any questions. Thank you.
Yeah, go ahead.
just wondering, because what I noticed from your data, both the Cohen and Ashwagandha, they do not act on similar pathways. So why I'm saying that is because the indications are different. Like some are due to inflammation, some are due to. Do we know which pathways are affected, or are they? So I'm trying to understand if there is a pathway that is caused the inhibition or overactivation that is causing the symptoms and how it's inhibited. Because what I'm thinking is that sometimes if the pathways are not known, then how do we ensure that the autophagy which is needed is inhibited by the dosage? What affects
No, not inhibited, activated.
that will cause negative, negative results in other parts of the body?
Good question. First thing, there are some common features. CoQ10 can act as an antioxidant on its own because it can donate one electron, accept one electron. And ashwagandha extract has been shown to activate NRF2 transcription system, which leads to activation of antioxidative defense system. So this is the more robust way to tackle the oxidative stress, direct antioxidant as well as activating the antioxidative system. Inflammation we have seen to be down by CoQ10 as well, but more prominently by ashwagandha. And ashwagandha extract has been shown to inhibit NF-kappa B related activation of inflammation in cellular system by others. Autophagy is to some extent exclusively activated by CoQ10. And this we have seen in the brain of the mice and rat in the Parkinson model too, as well as in the cells, actually very obvious. Okay? Activation of autophagy, so far, it has never been wrong to keep the cells healthy. If at all, some cancer cells evade cell death by activating autophagy. But that is when you get it. We are not there. So there are some common pathology or mechanistic views. There is one different difficulty with ashwagandha extract. We are not talking about one compound. This extract is a multi-component feature and which can target multiple pathways. There is a good review on this I was reading, it is part of my course. It can inhibit the production of amyloid beta. I didn't know that. It can inhibit the gamma secretase directly. So what advantage is that both CoQ10 and ashwagandha extract have been approved for human intake. So to use these formulations by getting approval from Health Canada and give them as a supplement to the patient and follow them up for a couple of years, and so if it halts the progression would be great. For that we'll need money, not me. Whoever company develops it, clinical trial is beyond our reach, but it could provide a big help. And that is only a small part. The big part is if it is proven that way, I should have been taking this supplement when I was 40 maybe. Okay, preventative. And again, through this course development, I found by and large, many of the natural extracts, colorful food, leafy vegetables, all of them have two things in common. They have anti-inflammatory and antioxidative property. So please, in our behavior, we should accommodate these to bring down at least 2 risk factors to keep healthy. And the third thing, which was very interesting, I find, that in ICU, I've seen people lying for only 2 weeks, and after that, their muscle fatigue, they can't even get up, the muscle got degenerated. Same thing could be with the brain if it is not active. So brain needs to be excited, activated all the time. And they say that one is to keep the brain happy. The brain can be excited in a wrong way also. You got hurt, somebody said bad, you got upset. That also is activation, not good. That is not one. Don't hurt it. Keep happy. there is a correlation that one of the reducing factor, risk factor is by volunteering. Many of you are doing it. I was trying to analyze how come volunteering helps with reducing the Alzheimer's risk. They say Alzheimer's, any volunteer goes home, and whenever he remembers this organization he was working or she was working, helping this patient, his or her life has been of use to someone without any interest. It gives an immense pleasure, much more pleasure than owning a BMW. And that one is the happy factor for the brain. And keep active. I'm very happy that the current generation of young people are diet conscious. I came to 92 in Canada, there was no gym. Now there is a gym at every corner. And no smoking. I think other than cannabis, people are doing right thing these days. Fantastic. Any other question? Yes, please. Mm-hmm.
That's great. Now, still, like, would there be an outside, like, maybe the device rest and do they sleep? Like, if you did lower something like the brain, if they're becoming exhausted because, they're functioning.
These people talk to them all the time. So generally, what I have been told that they look pretty healthy, nice, just by looking at their activity. And they are in the cycle of 12-hour dark and 12-hour light system. Do we have video there? Video constantly, video watching? But in the dark, they can't watch, right?
Well,
If they're sleeping or not.
well, so they sleep, they are nocturnal, so they sleep in the light time, but, not light time, sorry, they sleep in the light and they're awake in the dark. So, but our camera that we use to film them is infrared, so it does film in the dark because they are active in the dark. But we only film them in the maze, not in their home cages. But we do give them 24 hours rest in between each session just to control for exhaustion, because we have to consider all factors of the disease, which also includes mobility issues that come as the degeneration continues. So we do only keep them in the maze for 3 minutes at a time, 4 times a day, which is not a whole lot. And again, we don't force them to do anything. So if they choose not to explore in the maze, we consider that as their choice. So we still consider that in our data. So they can explore, they cannot explore. We're not going to force them to do anything, but yes.
Yeah, it's a very good question,
Yes.
though, the multifactorial way to assess that. And we can't compare human and mice. We had a Parkinson's project and we're trying the mobility. The mice is 4-legged, it cannot fall. We can fall. So, but there are some. One thing is that the ashwagandha has been in use in Ayurvedic literature for a very long time. And after 2012, it has been available in the Walmart, Costco, everywhere. People are using here also. It could be a good idea to find out, to properly clinically assess that what is the effect and behaviorally and so. But by and large, it is safe. That's what I was told. Yes, please. That is good.
Yeah, so good. Sorry. Good question. So your question, sorry, I forgot that we were supposed to repeat the questions for online.
repeat the
So
question. Yes, go ahead.
your question is, do we keep them in a group or do we keep them individual when we are taking analysis? Oh, yes, right. Specific to, right, for their social needs. Yeah, okay. So, so these are female mice, so they are social, and we do consider that. So we keep them in a cage with 3, so each mouse has 3 cage mates, 4 mice per cage, to make sure that they are socializing. And we did have an issue with whisker plucking, and with this, yeah, so I don't know why one mouse was yeah, I don't know. It was big bully in a cage. So the vet suggested that we separate the mice or separate this one whisker plucker, but we didn't want to do that just because we still thought that this mouse should have a cage mate just for socializing. So we did. We're still kind of playing around with the cage with the 2 mice per cage to try to figure out which mouse she's not going to whisker pluck. But yeah, they are socialized, and the experimenters do an excellent job as well as coming in every day, handling them, and giving them lots of treats.
They don't socialize among themselves. They socialize with the student too.
Yeah.
So we handle
Yeah.
them, cuddle them. Like,
Yes. I know it's funny, but a big component of our research is that we want to treat our animals how a human would be treated. So if we do take this to clinical trials eventually, maybe, if a big box of money landed on our foot.
Yeah. We don't really, one of the problem with natural health product or something like this is there are not big company interested in investing it because proprietary is a bit difficult. Even if we have proprietary, the clinical trial costs money and they have to recover the cost, and anybody can make this formulation later on. But my request to public agencies, the funding agencies, is to promote this. We had almost created a team here of geriatrician, Dr. Risa Parashar, Dr. Desai, and they said, yeah, we can do supplementary trial is rather easier because patients are not at risk. Whatever treatment is there, they can carry on. In addition, they can take the supplement, and placebo group can just take the water and then monitor them over time. But unfortunately, this company doesn't have money. Western Foundation had agreed to pay 75% cost of trial, but 25% has to come from the company and provide the formulation. Somehow it got stuck. I'm still hoping that somebody will take it up and develop. I want to take it before anybody else. Yes, please. Go ahead. Sorry, go ahead. No.
Go ahead. Sorry, do you mind repeating your question? So, so your question is regarding different tissues within the brain, not just the cerebral spinal fluid, right? So if they increase in gray matter or white matter or dark gray matter, would it indicate a prevention of Alzheimer's? Yeah, yes. We are exploring that right now. So we are, like I said, with the T2 weighted image, it does highlight the tissues with high water content. So that is easiest for us to segment out. But we are exploring the intensity ranges that are associated with different tissue types, like the white matter and the gray matter, because the hippocampus is gray matter. So to quantify how that volume changes, we are now just we're evaluating the ranges to get a standard for all of the mice. And same with the white matter. So the corpus callosum is very important, and that has been seen to shrink as well with Alzheimer's disease. And that on these images shows up dark. So but it's also the same, yeah, and it's complicated. But we did just collect these images a few weeks ago. So for now, we're looking at the inflammation because that is also a very prominent symptom neurostructurally at this moderate degenerative stage. So yeah, in the future, we are definitely going to be assessing
As a word
that.
of caution, mouse and humans very good.
Yeah, their hippocampus is
Whatever
huge.
indications we are seeing here, it can be passed on if it is all substantiated properly to the image of the human brain or the people who are there. And if they can make similar sense out of it. if even 10% of this knowledge can be translated into the human MRI, that could be of a great benefit.
Thank you.
People are tired.
Right on schedule, just before 8 p.m. Thank you again to our tremendous researchers, Dr. Joshua Armstrong, Dr. Jerome Cohen in absentia today, Dr. Siyaram Pandey, and Ms. Keanna Dube. We're delighted. Thank you also to Art Windsor Essex for the beautiful venue. We should acknowledge Time to Go, lovely local venue for the catering. They're located in Walkerville. They do our food for us, cater for us more often. Again, Time to Go. Wonderful. Please feel free to stay behind, enjoy more food, and visit. We're not in a hurry to get out the door. Would love you to do that. Please take any of the food or drinks with you as you wish. By all means, our pleasure. And thank you to Eugene. Eugene is right there at the back on my right. Eugene's been with us about a year and a half. Delighted to have him on our team. Feel free to contact him at any point in time if you'd like to volunteer or donate. And in that regard, we are a charity, the Alzheimer Society of Windsor and Essex County. We are in our 43rd year of service here in Windsor and Essex County. If at any point in time you wish to volunteer, if you'd like hard copies of the landmark study, Part 1, Part 2, give us a call, drop by our Walkerville office. We'll be happy to provide those to you. They're available online, of course. Love to hear from you. Please be in touch. I'd like to ask that all of you see yourselves as advocates for those of us serving in the world of dementia. Advocates representing people living with dementia, their care partners, as you go about with your family, your neighbors, your faith community, your different social groupings, your colleagues. As you go out in the community, remind people about dementia and the Alzheimer's Society, and we obviously have a very long way to go when we look out the next generation or so. We do not have a cure, and it's all of us together who will need to work together in this regard. Landmark study number 3 of 3, Dr. Joshua Armstrong thinks may be out January-ish 2025, let's say January to June 2025, all being well. We have part 3 of your study coming forward. I think it may call for a future research day. And we would love to have you back and look at local, national research. There may be some provincial research, other researchers as well that may like to join in. We can envision that and strategize as we move forward. But if anyone has any ideas in that regard, please let us know. So we're just past 8 p.m. Thank you again so much on behalf of all of us at the Alzheimer's Society.